See, good morning. I hope you're all doing well. Um, in this short video, I'm going to be covering cross-sectional data analysis, and I'm going to be using Stata to actually do it for you, and I'll show you how you can actually go about doing it. So, as you must have seen from the previous video, that before you can actually run a regression, you first need data. And even before that, you need to have a question in your mind that you want to test. In my case, I'm going to be discussing a question about wages. So as in the video, we were trying to explain how the world works, and we were trying to explain how people's wages are determined. And in the last video, we talked about how education can impact people's wages. So I'm gonna run you through the whole process. So let's imagine that I was curious about this research question that I wanted to test and see if I could figure out whether education did actually play a part in determining people's wages. So I went about doing a survey, and I gathered data from people, which I then entered into an Excel sheet. Or in Stata data file if you want to do that. And then I collected data. I'm opening my data file right now, and when I open that, let me just close this window, and let me just clear everything so that you can see how it look if you were to start from a fresh. Discard changes. So you'd open your data file up, the one that you made maybe in Excel or wherever, and when you open it up, you end up with this command that says use the wage data file that I just clicked to open. That's what the software is doing. And as we discussed previously in the on-campus class, the Stata application has some windows that we need to know of. When this results window shows you whatever you run will be reported over here in this window. The command prompt is where you can instruct Stata to do stuff. The variables will show you which variables you have in your data, and on top you can see a data editor where you can change your data, and a data browser where you can actually look at your variables. So you can actually use the variable manager to look at what variables you have in your data as well, or you can actually just go and open the data up and take a look at it. So if you look at this data, there are a total of 526 people who have responded to my survey. And out of the survey, what I've asked them is what their wage was, how many years of education they had, what their experience was, how long they've been currently working in their current organization, whether they're white or not, what their gender is, are they a female? Yes is a one, otherwise zero. Zero means this person at row 3 is a male, whether they are married or not. So 0 means not married, 1 means married, and then number of dependents and other variables over here that are included in the survey that I carried out. So you carried it out. You could have used a Google form for this and gotten these responses in an Excel file, and then you could have shifted them into Stata if you wanted. So once you have the data file, what I would recommend is that since you want to keep a record of what you are doing in Stata, I recommend that you maintain a do file. A do file tells you is basically sort of like a Word document, but it's a code file that will record whatever commands you want you want to give to Stata. So the first command was where I just copied it from the main command window, and results window, and I've brought it over here in the do file, and I'm going to save it as my do file, because my do file MBA, that's the name of the file I'm going to be using, and I'm going to save it. So the first thing, or the command over here, is that you write use data which is in this place, in this folder. So you give the Stata the directory that the data is going to be in. In the case of, since I'm using a Mac, in the case of Windows, you might find that the path is going to have the other the slashes are going to be this way. But if you have trouble finding this path, just open the data file in eViews and sorry, in Stata, and you'll be able to find out what the path is in the command in the result window. See, when I opened it, I found out the path. So now so now that you've loaded, so this is where you load your data. So remember from the video that the first step was to load your data. Now you have fed Stata your data, and that's the first command. So whenever you want to write a comment in your do file, you can actually do so with by enclosing it in this way. And notice that when you do this text becomes red and or green. But this suggests that what you've written is not going to be read by Stata when you run the file. It's going to be considered as a comment. So once you've made Stata to actually read the file, what's the next step? So before we get into actually doing it, let me just write down what we're trying to do. So we want to kind of figure out if education explains wages, right? So I and as we discussed in the video, the hypothesis is that the beta for education is going to be 0, and we want to reject this null hypothesis to prove that there is an effect of education on wages. So that's what we're trying to do. So in order to do this, if you remember from the video that you just saw, you have to actually first you can actually since we do have the data, you can actually make a graph for this. So the command for making the graph is since it was a scatter plot, so you say scatter, and then you add the names of the variables. And what are the names of the variables? You have to actually go into your Stata file and look at them. And remember that Stata is case sensitive. So we are going to be using wages and education are the two variables of interest. I can just copy it from here and just paste it. So uh, also, so once you've written this command, you can actually run it. To run it, you have a option where it says execute or do it. So when you click this, it will start reading from 1 and going downwards. Anything that you've brought into these brackets are going to be considered as comments, and the application will not consider them as code. So when you run this, um, sorry, so without selecting them, when you run this, um, this is what happens. You end up with a scatter plot. This is something that we saw in the video that I uploaded for you as well. And we can see over here that there is an upward sloping trend, which suggests that maybe there is a positive correlation between wages and education. To further confirm this, you can actually check the correlation, and the way to check the correlation is to just say correlate wage and education. And if you run this by selecting this, you can end up with a correlation. So see in the result menu, you can actually see correlation matrix, and you see that wages are correlated with education 40%. Right, so there is a positive correlation between wages and education. But like we said in the lecture, that correlation is not causation, and that is why we need to actually go about carrying out a regression. And so for regression, there are some requirements that are important. So in before we get to those requirements, the let's just recall what the model was. We thought that wages were going to be impacted by were going to be impacted by um, experience, tenure, and gender as well, besides education. So so when we want to control for these factors, when we want to investigate if the impact of education on wages. So the model that we are thinking about is that we think that wages are a function of experience, tenure, um, gender, and education. And if we want to figure out what the impact of education on wages is, we need to control for these other three factors. Uh, Therefore, there is this need for running a regression analysis. So let me just make these comments so that they are retained in the do file. Notice when you close them in brackets, they go red, which means that the software does not consider them. So in order to run the regression, the command is simple. All you have to say is regress, and then you need to put your dependent variable first. So you're trying to explain wages, and then you're trying to explain them through education, and the other factors that you want to use are experience, tenure. So experience matters, tenure matters. Notice you looking at this to actually decide, and then female as a variable for gender is also included in the regression. So once you've written this, you can actually run the regression now, and the results are going to be reported in the results section over here in the result window. So once you select this and go to execute, the regression results can be seen in the results window, and here you are. These are the results that you saw in the video that I shared previously. Now, before we that's how you run the regression, and we've talked about how you can interpret these betas and what they mean. Um, However, um, it is important to remember a couple of things about running regression. So there are some requirements that need to be fulfilled before a regression can be run. So these requirements for regression, one requirement for running a regression is that you cannot have. So the first requirement is that data needs to vary. So you can't collect data on education from a class of MBAs, because then everyone would have 18 years of education, and then the variable education would not have any variance in it. Understand that when you're talking about regression, you're talking about variance analysis. So first requirement is that the data needs to be vary. It's to vary. So how do you check this? So in order to check this, you can actually see the summary of the variables. You can look at them and see. So if you say sum is summary of your variables. So rather than summary, Stata says use sum, and then if you execute this, you'll get a description of these variables. You'll get what's called a descriptive statistics of your variables. So if you just run this, notice that in the window you get a table that looks something like this. So it talks about wages how many observations you had, what is the mean value of the wages, what is the standard deviation, what is the minimum maximum. Looking at this, you can see that the value of the variables is changing in the sample that you collected. Um, Education is also varying, starts from 0 education to 18. Experience starts from 1 year to 51 years of experience. Tenure is 0 years of experience in a particular firm to 44 in the same firm. And then you have 0 for female males and 1 for females. In our sample, 53% are males and 47%, 48% are females in the sample as per this value. So now that you've verified that your data has variance in it, the second requirement is data needs to be normally distributed. Now with normally distributed data, what we're trying to look at is one thing that helps is when if data has variance in it, that we've actually seen. Secondly, in your stats class, you talked about how data norms generally starts to become normal when when the number of observations crosses observations when the observations cross 30 in number, data starts to become normal. If you look at this data where we have 26 observations, and so we like to assume that this data is normally distributed around the mean. However, the second thing is that sometimes means are data has some outliers in them, and so when you're running your regression, you need to be wary of what's called outliers, and outliers are by definition observation values that are, to be on the safe side, 3 standard deviation away from the mean. I believe we've already discussed this, so I'll not go into a lot of detail about how you can use this table to see whether the mean is 5, 1 standard deviation is 3.6, so 3 standard deviation would probably be 9. So 5 plus 9 would mean that any value above that, wages above that, would be outlier cases. So in this case, it seems as if 24 is an outlier. There's somebody over here in the sample who has very high values. So if I were to say drop wages if drop if wages is greater than equal to, maybe in my case 18, let's say, so that we don't end up dropping a lot of values. Drop wage. Notice how not spelling the variable correctly have issues. So you find out that out of 226, there were 12 values that were extreme values. I just dropped them, and when you do the summary again, you can now see that it's now below 80. So this way you can actually look at the data and make sure that there are no outliers in the data, because outliers are going to be distorting your results. So 1, data needs to vary. 2, data needs to be normally distributed. 3, the data needs to not have outliers. 4th is about this issue where when you have a model that looks like this, remember that this wage is your dependent variable, and the remaining variables are these guys are your independent variables. So what's happening is that you're trying to explain wages through these IVs. What is required with running regressions is that you don't have two independent variables like tenure and female that are highly correlated. So two IVs can't be highly correlated. And how do you define highly correlated? They shouldn't have a correlation of greater than 0.8. Um, so correlation should not be greater than 0.8. And in order to check this, you can actually carry out correlation analysis. You can actually see what correlation of the variables looks like. So you can use the command correlate and add the variables, and when you execute this, you end up with a correlation matrix that shows you some correlations. Notice how wage is 39% correlated with education, 8% with experience. If this value was greater than 80%, so this is a high correlation. Experience and tenures are almost 40-50% correlated, but not highly correlated. So for highly correlated, they need to be greater than 80%. So your benchmark is no independent variables should be uh, highly correlated. Notice that it doesn't matter if these are highly correlated, because this is the DV and the IV's relationship. So once you establish, and when can that happen? It can happen if you have a variable that looks like experience in years, and then you have experience in months. So both of them would be the exact same thing. So the idea is that you don't have two variables that are actually measuring the same thing in the same regression model. So you can do that. And another way to actually check whether your and this problem of having two variables that are highly correlated is called multicollinearity. Multicollinearity, and you want to avoid this. The next thing that we want to talk about is that another way to actually check whether your data is free from multicollinearity is to actually run the regression and then run this command called VIF. This is the variance inflation factor command, and the values that you end up with when you run this command should not be greater than 10. Let's say if you have variables that have values greater than 10, you have a problem of multicollinearity. So if you have the problem, you have to drop the variable, or you have to transform the variable, take a log, and see if you resolve the issue. If that doesn't help, then you actually try to take uh, subtract the values from the mean. That's called demeaning, and maybe that helps you. If that doesn't resolve the problem, then you have to drop one of the two variables that are highly correlated. So notice that once you run the regression and you run the VIF command, in our case the VIFs are less than 10, so we are good. Our model does not have multicollinearity. Besides this, there are other issues of heterogeneity, and then there is something called serial correlation, and non-stationarity and stuff like that, but that's something that has not got a lot to do with cross-sectional data, so we for the time being are not going to be going to that. So just to reiterate, for running a regression, you need to make sure your data is normally distributed. It varies. You need to make sure that no two independent variables are highly correlated more than 80%. You can use the correlation matrix for this, or the VIF test, to actually show that this is not happening. And once you're done with this, you have actually run the model, and you end up with so your final regression looks something like this. So I'm going to be you run this, and you end up with your findings, and as we discussed in the video, 35% of the variation in wages is being explained by our four variables, and then we talked about how you can interpret these coefficients. Size matters and the p-value matters. Now for you guys, what I want you to do is actually I'll be sharing this do file and data file with you, so you'll have all of this data with you. I want you to answer this research question for me, and this research question that I want you to answer is, how does um, being non-white impact people's wages? Wages. That's the research question. I feel as if you are non-white, you'd probably be getting paid less. But can you actually prove this? Is that true? Um, I want you to using this data that I provided to you with, see if you can find a variable that captures this effect in the data file, and do an analysis on this and report what you find. And also, the second hypothesis that I want you to test is, how does being married impact people's wages? Remember that when you are interpreting results, um, that these variables, marriage and being non-white, uh, these variables that you use in your regression are taking the value of 0 and 1, and these are called dummy variables. And the interpretation of the dummy variable is that if whatever is the coefficient, so for example in this case the coefficient of a female is of a female, which is a dummy variable, plus 1, takes the value of 0 1, 1 for female, 0 for a male. This minus 1 basically says that females have wages that are less than are compared to the male, they are lower by this amount. So what I want you to do is carry out these two hypotheses, and then I want you to write a document where you report all your diagnostic tests for the regression, and you say that I've done a correlation analysis, I've done um, um, a VIF test, I've seen the data and I've seen the descriptive statistics, and I see the data is normally distributed and I don't have outliers, and after that I've run regression, this is my finding and this is what the findings say. So you need to do the whole regression and report your results in it. Um, so good luck. This is going to be a 3 hours activity that I'm going to be marking for you. So good luck, and if you don't have eViews, you can actually try to run this in Excel as well. Maybe this is going to be possible, a little difficult, but possible in Excel as well. So good luck.